Got it. I have to write a final exam soon too. Okay. So let's see here. We have, this is going to be problem number 6. Okay, so this little piece today, that'll be 6, 7, 8, and 9. Okay. So let's see here. We have an equation. The equation of an ellipse is given below. So we're given the equation of an ellipse. It's at the bottom. All the instructions are up at the top here. X squared over 45 plus y squared over 6 is equal to 1. And then we ask a whole bunch of questions about it. And I think I gave the standard form of an ellipse, right? I think I gave you guys this. I didn't give any explanation about it. I figured, you know, you would have done enough problems to know that the center is HK, right? So since there's no H, right, and there's no K, I mean, they're both 0. It's X minus 0 squared. Then in this case, our center is 0, 0. Okay, not so bad. So 1 center, right, 0, 0. 2 is I ask you for the vertices, and that's on the major axis. Okay, that's the endpoint of the major axis. And that's the longer one. So if we set y to be 0, okay, we have x squared over 45 is equal to 1. X squared would be 45, which is 9 times 5, right? And x would be plus or minus the square root of 45. You don't have to do all of these steps, but 9 square root of 5. And what I really want to see is x is equal to plus or minus 3 root 5. So the vertices are 3 root 5, 0, and negative 3 root 5, 0, because it says make your answer in terms of ordered pairs. So just like the Connect Math, right, we have it something like that. Okay. And then it asks, okay, well, what are the minor axes, right? What are the minor? And I think that's actually how they spell it, is minor axes. That's how they say it. Minor axes, endpoints. And what you're supposed to do there is set x equal to 0. Okay, so we're going to have y squared over 6 equals 1. Right? So y squared over 6 equals 1. In this case, 6 doesn't have a perfect square in it, so we just have y squared equals 6. So y is equal to plus or minus root 6. So the endpoints are going to be x is 0, y is root 6, and 0 and negative root 6. Okay, so those are our minor axes, and that would be our answer for that one. Okay. Let's see, the next thing I have is do, so that's part 3. Part D is identify the foci. Okay, and I gave you the formula, right? I said this was c squared was equal to a squared minus b squared. And on this formula, right, I assume that the a is just the bigger one. I'm kind of assuming that you guys would know that. So it's just the bigger one squared minus the little one squared. In this case, the a really is our x because it's the bigger one squared. But yeah, it's one of those things where it's like if I swapped them, I would kind of expect you guys to not miss a step and just swap. You know, take the big one minus the little one, even if it was written second. So c squared is equal to 45 minus 6, which I believe is 39. That's 3 times 13, so that is not going to be a very nice square root. So c is equal to the square root plus or minus 39, and it's plus or minus root 39 from the center. So it's always good to, put that in there. I wouldn't expect people to do it, as an answer to a test question. But if the center was somewhere else, right, you have to realize, like, well, the foci is, it's root 39 away from the center. So my center points, and again, it says list them as an ordered pair. So we're going to have square root 39 for the x part, right? And negative square root 39 in the other direction. So those are our foci. Okay, I did not ask eccentricity, so I didn't give you the formula for it. I learned because I used to give my stats students the formula for standard deviation, even though that was entirely a calculator exercise. And a lot of my students said, well, you gave us the formula, I'm going to use it. I never asked you to use it. But, so I didn't want to confuse anybody and make that worse. And then we have to go ahead and graph it. Okay. Let's see, square root of 6 is somewhere between 2 and 3. So here's 1, 2, 3. So we'll say the square root of 6 is in here somewhere. So this is square root of 6. 1, 2, 3. We'll say the negative square root of 6 here. And then 45, we have square root of 45. I know it's 3 root 5, but that's close to 7, right? Because square root of 49 is going to be 7. So we'll go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So we'll have our points here. We'll have our point here, point here, point here. And as long as you're, at least as accurate as I am when you're drawing your ellipse, I think you're doing great. Okay. And as far as my drawing skills, I think a third grader could probably do a better job. So, that's the standard. Okay. So pretend that looks more like a football than it does. Okay, than a clamshell. It's not supposed to have like sharp edges. It's supposed to be rounded. But there we are. Okay. So that's it. Okay. Sometimes we get really into having you guys rate the axes, and I'll tell you that if you're going to go on to engineering, I had a teacher who, you have to draw all this stuff for engineering, and you have to label it. Here's your free body diagram. Draw your little, pipe sitting on a plank or something like that. And then put your forces here. Maybe somebody's standing on it, so you've got forces going on. You have to identify all this stuff. And I remember I got about a 50% on a test because they were all right. But since I didn't put the little X and a little Y on my axes, I didn't know what you're talking about. Didn't have your coordinate system labeled. I was like, you took half for that? Like, yeah, half for the first mistake, half for the second, and then we stopped grading. Thanks. I'm going to drop your class now because I'm not going to suffer this. But I didn't say that. Just dropped. I didn't. He doesn't. I don't need his permission. He doesn't want to hear it from me. So that was that. So you should get into the habit, and especially when we do statistics, that class, like I'm a little bit more detail oriented for that because they're usually word problems, and you want to make sure if you're working a word problem, you definitely want to make sure your axes are labeled because it's not just X and Y. Okay, it's like years and population or amount of fertilizer and how many pounds of tomatoes you get. But I just try to get in the habit of doing that regularly because I've been dinged for it in a way that, wow, that's kind of harsh. Okay. So next one. Okay. So, it says write the standard form of an ellipse subject to the following conditions. Okay, so I tell you the standard form. I think I did. No, I didn't. It's in the extra problems. Okay. So there's your standard form. That's going to be in problem number 10. Okay. It's a true or false question with a whole bunch of things under, a whole bunch of formulas underneath of it. The answer is true. Okay. So let's see with that one. we have vertices, okay, at 5, 2 and negative 5, 2, okay, and foci are at square root of 6 comma 2 and negative square root of 6 comma 2, okay. So notice my x values, right? They're very symmetric. So I'm going to think that my center point for my h is going to be 0 because these are not offset. I mean, they're still going to be the same distance away from the formula, so, or from the center. So if this was like a 4, negative 6, then I would think like, wait, maybe my center is not at the origin. But since it's plus or minus, my center's got to be where x equals 0. Okay, so the center, you know, we could say that. Okay. Now the y part, right? The k. Notice that they're all 2's. Okay, and since the foci are square root of 6 away from the center, the y part, right? That's k is equal to 2. Okay, so far we have x squared over a squared plus y minus 2 squared over b squared is equal to 1. All right. Now, let's see here. If my y happened to be 2, right? If my y was equal to 2, what would happen here, right? We get x squared over a squared would be 1, and I know that answer is plus or minus 5. Okay, so when I say x squared equals a squared, I know that this answer here is 5 because we're plus or minus 5 away from the center here. So my a squared, right? My a squared is equal to 25. Okay, it's equal to plus or minus 5. Okay. And now the only thing I have to deal with is my foci, right? Which is c squared is equal to a squared minus b squared. Okay, well, I know a squared is 25. And then c, right, is equal to square root of 6. So c squared would be, right, 6. So we can go ahead and put the b squared over here is equal, put the 6 over there, 25 minus 6. What is that, 19? B squared is equal to 19. I think we're set. Okay, so we have x squared over 25 plus y minus 2 squared over 19 is equal to 1. And that's our equation of our ellipse in standard form. Okay, so it requires you to use the formulas that you're given, and you have to kind of piece together what's going on here. Okay, but those are the that's the problem really. Okay, so a little confusing, a little tricky, but not too bad. Speaking of tricky, okay. All right, problem number 8 here. This one looks like 7x squared minus 5y squared minus 28x plus 10y minus 12 is equal to 0. And I say, write the equation of the ellipse or hyperbola in standard form. All right, now for the equation of the hyperbola, the equation I gave you was plus or minus, right, x minus h squared over a squared plus, and then I put minus plus in here, y minus k squared over b squared is equal to 1. The fact that we have a plus minus and then minus plus is there to signify that if you choose the top one, you got to choose the bottom one. If you choose the bottom one, you got to choose the bottom one. Okay, so they have to match. Top goes with top, bottom goes with bottom. All this is trying to say is that they have mixed signs. Okay, and again, your book says a squared has to be the bigger one. I'm going to assume that you're good enough to like swap the letters. If y happens to be the big one, you can make this one a squared and that one b squared. Okay, so I'm not trying to, oh, I should have added to that one. Dang it. Oh, well. But I'm not trying to trick you with the formulas. I'm just trying to make it simple so that, you know, it's not, it doesn't take up a whole matrix of a page of coming up with um, all the different scenarios and all the different conditions that a hyperbola is going to have. So kind of trusting that you've done enough problems to be able to make that adjustment. Okay. So here we have a problem. You're like, who wrote this problem? God, this is terrible. So what we're going to do is we're going to group all the x's together. Okay, so we're going to say, well, that's 7x squared minus 28x. Okay. And then we're going to group the y's together. So that's going to be minus 5y squared plus 10y and is equal to 12. Okay. I left some space because we have to complete the square twice. Okay. But the first part of completing a square is we got to have a coefficient of 1. So really what we need here, so I'll do those, is we have x squared minus 4x, okay, minus 5. We're going to pull out the 5 here. And we have y squared, don't forget the minus sign, okay, it's equal to 12. Okay, so now we have to do the complete the square. This one, wow, they were really kind to us. Okay, when I pull these out of the book, or I pull these out of the homework, I don't want somebody to say, well, this one was demonstratively harder than the one you gave us in the pretest. So all I did was just have, you know, when I pick a problem, generally I pick the one right after it, or I just have it randomize a new set of numbers. Okay, because I don't want to feed you this on the pretest and then give you the harder one on the test. If I give you a harder one on the pretest and there's an easier one on the test, I make no apologies. But I don't want to deal you a problem that is more difficult on the pretest or on the test than you had to deal with on the pretest. Okay. So we identify the middle term. Okay. Oops, minus 4. Sorry, I'm jumping ahead. Okay. Take the middle term divided by 2. It's negative 2. Take that middle term that you divided by 2 and square it. That's 4. So we're going to add. Should have left myself more room here. Okay, we are going to add and subtract this value, right? Because we're just adding 0. Same thing over here, right? We're going to say b is equal to negative 2. B over 2 is equal to negative 1, right? Half of that. And then b over 2 squared is equal to 1. So we're going to add and subtract 1. But we're not really adding and subtracting 1, are we? We're adding like negative 5 and then adding 5. So we'll get to that in the end. But this way keeps the accounting of it kind of self-contained. We don't have to think about extra stuff. There's tons of ways to learn to complete the square. A lot of them are confusing. Okay, sorry. I like to think that my way has the least confusion, or at least minimizes the confusion, but I don't know. I don't see it through your eyes. So complete the square on this, right? That's y minus 2, or x minus 2 squared. We have a minus 4 sitting here. Okay, minus 5. We have to complete the square on this part here. That's going to be, right, y minus 1, because that's a minus there, squared. Okay, minus 1. Oops, not that bracket there. Okay, minus 1. That equals 12. Now we're ready to untangle and deal with the accounting and all the housekeeping stuff with like adding 1 or 4. So we have 7x minus 2 squared minus 28 minus 5 y minus 1 squared plus 5 is equal to 12. So you see how that happened? We just distributed it. Okay. So what we're going to do now is we're going to add 28 to both sides. and we're going to subtract 5 from both sides. Okay, so we're not quite there yet, but we're getting close. So we have x minus 2 squared minus y minus 1 squared. Oh, there's a 7, there's a 5, and that equals. And now we have to figure out like what all of this stuff is going to equal. So it looks like we have 12 and 18, which is going to give us 30 minus 5. I thought this was supposed to give us 35. Well, it didn't. Okay, unless I screwed something up, did I? Oh, this is a 28. Of course it is. Okay, there we go. So, yeah, this is going to be 30, 40. 40 minus 5 is 35. Okay, so almost there. Got to divide everybody by 35 because standard form for hyperbola has a 1 over here. So this is going to be 7/35 x minus 2 squared minus 5/35 y minus 1 squared is equal to 1. Hey, what is 7/35? Right? Isn't that a fifth? Right? 7 times 5. So that's x minus 2 squared over 5. Okay. Minus y minus 1 squared over 7 is equal to 1. Hooray, now we have it in, right? That's our standard form. Okay, so that was the first part of it. It was like, write the thing in standard form. And then I ask you to identify some things. I say, well, I don't think I asked you to graph it for this one. I think this one I left you to not graph it. I hope I didn't. Yeah, I don't think I did. I don't think I asked you to graph it. I will just in case I forgot, but there we go. So where's the center? Right, the center is at 2, 1. Okay. So remember that negative sign that belongs to the formula that doesn't come with. So unlike quadratic formula, then it does. But this was written. Conic sections have a little bit different rule system because it was not during the same time period. Okay, what are the vertices? Okay, if I set x to be 2, okay, so if x were equal to 2, then what I'd have is negative y minus 1 squared over 7. So wait a minute, that's the negative one. This is not the real part of the solution. So this hyperbola, right, looks something like this. Right, it goes from side to side, not up or down. So not this one. Okay. So this is not where the vertices are because this one's negative. So it must be in the other spot. It must be set y equal to 1. So that term drops out. We have x minus 2 squared over 5 equals 1. So here we have x minus 2 squared is equal to 5. Then we'll have x minus 2 equals plus or minus root 5. And x will equal 2 plus root 5 or squared. No, it isn't, not anymore. 2 minus root 5. Okay. So where are the vertices? The vertices are at 2 plus root 5. What was y? 1. And 2 minus root 5, 1. Okay, those are my vertices. Okay. Where are the foci? Well, remember, and again, I gave you this formula, so I'm not trying to make it harder than it really needs to be. Is c squared is equal to a squared plus b squared. But it's which one's a, which one's b? Well, a is technically the bigger one, but since we're adding, it doesn't really matter, right? That's just going to be 7 plus 5 equals c squared. C squared is equal to 12. So c is equal to the square root of 12. 12 is 4 times 3. So c is equal to plus or minus 2 root 3. Okay. And yeah, I expect like 2√3. I don't expect the decimal approximation. Don't do that. Okay. So it says give an exact form. Okay. So, and again, it's from the center, right? It's this many units from the center. Where the heck is the center? The center was at 2, 1. So this would be 2 plus root 12, right? 1. And this would be 2 minus root 12. That's not minus 12. 2 minus root 12. 1. Okay. Or to write it more politely, right, we'd have 2 plus 2 root 3, 1, and 2 minus 2 root 3, 1. Those would be our points. I did it this way first because I didn't want you to get confused with like, well, wait a minute, it's 2 root 3, what's happening here? So I put it in the original form just to make things a little bit easier, and then I translated it. Okay. And I think that's all they asked for. They wanted to know the foci, they wanted to know the vertices, they wanted to know the center. We'll go ahead and graph it just for the sake of completeness, but I don't think I asked you to do that. We're at 2, 1, aren't we? Oops, let me erase this. Wait, our center was at 2, 1. So most of our action is going to be taking place over here. So there's our center. Okay. Where are the vertices again? Well, the vertices were 2 plus root 5 and 2 minus root 5. 2 plus root 5. Root 5 is like 2 point something. So we'll call this 2 plus root 5 here. Notice my y value, still at 1. And then 2 minus root 5, we're going to be like here somewhere. We'll put it right there. Okay, this will be 2 minus root 5, 1. All right, those are our vertices. What we have to do at this point is we have to move up root 5. We have to move. We're moving root 5 over from 2 and root 7 up. So here we're moving root 5 over from 2. We have to move root 7 up. So maybe about there, maybe about here. So what is this point? This is 2 plus root 5, comma, 1 plus root 7, right? This point here, this is 2 plus root 5 minus, or 1 minus root 7. Okay, and that's our box, right? That's part of our box here. Same thing with this one. Okay. Okay, and then all we're gonna, I know I didn't ask for the asymptotes on this one because that's gonna make this a really long problem. And I'm only grading it out of 6 points, and that's too much at this point to start asking about everything else. Okay, so those are my asymptotes. Let's see, go back to blue, and we'll go to a different color. We'll go to green to type this thing in. So here's my, so we get the vertice here. We are hugging our asymptotes. Okay, and that's our graph. Again, don't think I asked you, but just in case I did. All right. Let's see here. So that was number 8. All right. Was our penultimate problem. Number 9. Not do this again here. These cubes. I don't know. I don't like doing long tests. So this is the equation of a parabola And again, I gave you this. I said this was x minus h squared is equal to 4p, really row, but y minus k, right? And I asked you to do a couple of things. We're going to identify the vertex, right, which is hk, okay? The vertex is hk. Identify p, okay? And again, you're going to have to see number 10 to get this formula, okay? And again, this is going up and down. If I handed you one that has the y squared term, I would just kind of expect you could, kind of cross it over and do it sideways. Okay, what's the focus? Remember, the focus is p units above the center. Okay, and what's the focal diameter? Oh, that's going to be tough. Right, that's the distance of the line that goes to the focus. Okay, so, oh, did I ask about the latus rectum? Maybe I did. I think I asked about the equation of vertex, or equation of directrix. And 6 is endpoints of the latus rectum. That's the points where it intersects the parabola, right? Where your focal diameter intersects the parabola. I don't think I told you this. I wouldn't really have a problem putting that in there, but I figure once you guys do it on the pretest, you'll remember. Okay, x minus 3 squared equals negative 8y plus 5. Okay, there's the parabola that we have. Okay, so let's just check this off. Identify the vertex. That's 3, negative 5. Pulling the h and the k away. Okay. 2, what's p? Well, we have 4p equals negative 8. I think p is equal to negative 2. Okay, so this is a parabola that's going to do something like this, right? Down here, 5, we're going to be looking at a parabola like this, right? Because it's going to go down. Okay, let's see here. Focus. So remember, it's p units away from the vertex. So let me make a better drawing. Okay, we're going to be in quadrant 4, so I'll try to draw it so that it focuses the action over at quadrant 4. X, Y. So where are we? 1, 2, 3, 1, 2, 3, 4, 5. Okay. So our focus is going to be 2 units from the vertex right in the center of where this parabola is going to be. So we're going to have something like this. So my focus is going to be here. Where is that? Okay. So that's x is equal to 3 still, right? Y is equal to negative 5, negative 6, negative 7. Okay. 4 is the focal diameter. Right? Wasn't that equal to 4p? Right, if I go through and do this. Okay, so if I know that my y value is negative 7, can we solve for x? Okay, going back up to my value here. So let's go ahead and do that. We have x minus 3 squared. What am I doing with this? Okay, we have x minus 3 squared is equal to, we have here negative 8, and then we're going to set y equal to negative 7 plus 5, right? Yeah. So negative 7 plus 5, that's going to be negative 2. times -8, x minus 3 squared. So x minus 3 squared is equal to 16. Let's take square roots of both sides. So we have x minus 3 equals plus or minus 4. We're just going to add 3 to that. So we have to go from x is equal to 3 plus 4, and x equals to 3 minus 4. Okay. Those, by the way, endpoints of your lattice rectum now. Okay. So that's going to be at the line that runs to the focus. So y is -7. So my values here are going to be 7, -5, right? And -1. So I drew this terribly, okay? So we have -1, negative, -1, -5. Okay, once I get more information, we'll be able to do that. So 7 minus -1 is equal to 8. Focal diameter, distance is 8. Okay, and we got the lattice rectum in the same breath, so great. The directrix, it's p units in the opposite direction. So here we are down at -5. We're going to move up 2. We have y is equal to -3. That's my directrix. Okay. So wait, where are we? Okay. Yes, the focal diameter was 8 because we had our x values were at 7 and -1, and y is not changing. So it's 7, right? 7 minus -1. That's how we got the 8 for the focal diameter. Okay, so focal diameter, just take the 2x values that you have and subtract them, or go the other way. Okay, you bet. Okay. I know it's not the most organized thing, and I apologize for that. I should be better about my board space and stuff, but there we go. So I think the next thing we have to do is we have to graph it, but let's go ahead and summarize all the pieces we have so that the person grading this is going to have an easier time in their lives. Okay, so vertex is going to be 7 or 3 -7. Okay. 2, we have our p, which is equal to -2. That one wasn't too bad. That one, we did that one okay. Okay. Our focus. Okay, our focus was 3 -7. Okay. 4 is the focal diameter. And that was 8 units. 5 is the equation of the directrix. And that was y is equal to -3. 6 was the endpoints of the lattice rectum, which are the endpoints of your focal diameter. Okay, so endpoints of lattice rectum, and that is going to be, actually we did these, that was going to be 7 and -1. So 7, -1, and it's on the same line, right, as the focus. And we said that was going to be, right, that was going to be -7. All right. So there we go. And last thing here for graphing it. So now that I have the information sitting here, I'll probably have a better chance of graphing it. So we'll be a little bit more careful. Okay. Here's my y. And then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So what was our vertex? Was 3. Was it -7? No, it was -5. I'm sorry, I lied to you. Vertex was -5 here. Okay. So 3, 1, 2, 3, 4, 5. Okay, that's my vertex. Here's my directrix. Oops, wrong one. Okay, our focus was at 5, 6, 7. Okay, so here's my focus. And then the value here, right, that was -1, 3, 4, 5, 6, 7, 8. Okay, so I've got some points to aim for. Right, and there's my lopsided and poorly drawn parabola. Okay, so there we have it. Okay, that's probably too much of a, I think I went a little overboard for 6 points for that one. That's probably too much, but it's already written, so there we go. Okay, sorry about that. All right, so that pretty much ends the whole, like, that's the test. I know it's a little bit long. I gave you guys 2 hours to do it. I think that's the maximum allowed. I don't enforce an end time, so I just give it minus, it just has 120 minutes. If you go over, some people have before, I don't really, I don't penalize you for that. It's just like, it's just how long it takes. So when you're done, take a picture of your stuff, upload it as JPEG or as PDF. PDFs are a lot easier, but some people have posted them in a Word document. That works too. But like I have Windows machine, so I can't open a Mac. Okay, Macintosh pictures. I don't. It's like an HAIC format, and I downloaded an app to open those, and my computer immediately said, "Nope, we're not doing that." So please don't upload them that way for me. Okay. So that does it. Next week we'll talk about reviewing for final and what we're going to do there. But that should be about it. You have until the end of the semester to do this one. So I'm going to go ahead and stop recording here.